Let me start by expressing my sincere thanks to the organizers, especially to Garg Saab, for inviting me to make this technical presentation. And the situation is very funny. We have got more panelists than, than the listeners. But let us start and let us do something. I just hope it will be useful. And I don't know whether it will be useful to you because my topic will be basically related to construction. How the waste is being utilized in the concrete construction, that will be my topic. And I will be covering a large number of waste which is used in bulk in the cement and concrete industry. Let us start with a few general points which you may be knowing, but just to remind you, we all know our planet is warming up. And the present level of warming is around 1.2 degrees Celsius, which most of you must be aware. And even with this level of warming, there are unprecedented occurrences of extreme weather events. Many weather events. It could be heavy precipitation, forest fire, cyclones, all. We are all experiencing it. Every season we are experiencing it. And along with this global warming, the debate between development and environment is also getting hotter. It is getting heated up. Along with the warming up of the globe, our debate is also getting heated up. And we should remember, we all crave for development. It's a human instinct to develop and develop and develop. And we want better facilities, better comfort, better convenience in every walks of our life. And that leads to development. But one basic fundamental fact should be in the back of your mind whenever you think about development, whenever you think about advancement. And the question is, I'll read it out. In the process of development, if our planet becomes uninhabitable, what is the use or what is the meaning of development? This fundamental question should be in the back of your mind whenever you think about advancement or development. And whenever you talk about sustainable development, this diagram comes into picture. I think all you must be aware, you must have seen in many presentations. I need not explain it, but only one fact, just one issue I want to highlight. The window available for sustainable development is a very narrow window. And sooner or later, we have to confine our development within that narrow window. And sooner it will be better. And to come to that situation, to restrict our development within this narrow window, first of all, we must be more responsible towards environment. And we must certainly modify our environmental behavior. This is a fundamental mindset change every citizen of the planet should do to achieve that sustainable development. Coming to concrete, I don't know, you may be aware of concrete, most of the people must be aware. Concrete is a widely consumed construction material in the present time. And it has been used for a long time. This is a material which has been used for centuries. It's not a new material. It has been used for centuries. And the versatility of this concrete makes it one of the most ubiquitous construction material of modern world. Present day world cannot think about a development without a simple material called concrete. So indispensable, so ubiquitous a construction materials. And interestingly, this consumption is next only to water globally. It is second only to water in consumption globally. So this is an indispensable material. Even though it looks like a very common, worn out gray material, but without this simple material, you cannot move forward. And this you must have seen, at least some of you must have seen this diagram, very interesting diagram. The caption itself is very captivating. I will read it out. If concrete was a country, it would be the third largest carbon emitter in the world. It's a caption. I also go through social media, this diagram, but very revealing. After China and US, concrete is the most damaging element to the environment. The third largest emitter of carbon dioxide if you compare it as a country, as a single material, how much it can create damage or difficulties to the environment. So concrete industry has found out, they came up with mitigation measures. Many mitigation measures were adopted by the construction industry, and one of the major measures are encourage the use of waste materials. They have taken many steps. One of the major measures is to encourage the use of waste materials in their new construction. So this waste utilization, large number of materials are being used in the waste utilization in the concrete industry, and they are used both in the cement production and also in the concrete production. Both levels it has been used. And considering the quantum of concrete, I already told you, it is second largest consuming material, next only to water. You can understand, you can imagine the impact of utilizing waste in this single material. And the potential of using further materials is also very, very high. We have got two. One is waste. We can have many waste material. Finer waste materials are available. Coarse waste materials, coarse waste materials are available. And both these type of materials are used in the concrete and cement. In cement, the finer material we use is fly ash. It is a waste from power industry. Then we have got blast furnace slag, GGBS. This is a waste from steel industry. And these materials are used in large quantities in the cement and concrete. So in cement we use fly ash as well as slag. And in concrete, in addition to fly ash and slag, we use microsilica. We use rice husk ash. That means the husk is burnt. You get a finer ash that is being utilized. And it is allowed by the courts, Indian courts. And to a large extent, it is not a small quantity. The court permits a large extent, large quantum of use of this waste material. See, fly ash code allows 35%, both IS code and IRC code. It's a substantial replacement of cement. And GGBS, you can go up to 70% of the cement. Just imagine to what extent we are using the waste in our concrete construction. Similarly, there are coarse materials. Many coarse waste materials are available from the industry, and the industry has taken firm steps to use a large quantity of these waste materials. And the coarse category, we use iron slag aggregate, steel slag aggregate. This is all waste from the industry, various industry. Copper slag aggregates, bottom ash again from power industry. Then aggregates extracted from C&D waste. C&D waste he is going to cover. A large quantity of C&D waste aggregates are used in the constructions. It's all available naturally. Without much processing, we can use it. And to a large quantity, we are using it. And coming to C&D waste, I'll spend only one or two slides because he's already covering that, this one. So recycled aggregate C&D waste is used in a variety of applications. A large number of applications, we use the aggregates extracted from the C&D waste. Some of the usage I will mention. In the building industry, we use in lean concrete, in paver blocks, masonry blocks, etc. This is being used and allowed to use by the court. Even structural concrete, it is allowed to use these waste materials. And similarly, in the road sector, a variety of applications are being done. And the base courses, sub-base courses, DLC, that is dry lean concrete, pavement quality concrete, asphalty concrete, and even manufacture curbstone paving blocks. Large number of use is available in the highway sector for these waste materials. And this waste material usage is ably supported by the courts. The code-making authorities, either BIS or IRC, these are the main two code-making authorities in India, both has come up with codes that allow the use of these waste materials. And now they allow the use of this waste material. Previously it was not allowed. IS 383 is the code for aggregates. Prior to this one, this was revised in I think 2017 or 18, that's what I remember. Prior to this revision, waste materials were not allowed in concrete. Only stone aggregates from natural sources were permitted in concrete. Code has made a very drastic change, a fundamental change. Now it allows aggregates from the waste sources also. So it permits coarse aggregates other than natural sources, and they allow the part replacement of these waste aggregates in place of the natural aggregates. And very interestingly, code forcefully not only allows, it forces you to use it. It recommends very strongly to use this material. I'll just read out. This is a clause from the code. It's not my wording. It is a clause from the code. Engineers should take initiative to use these waste-based aggregates wherever found feasible and available for the cause of sustainability. That is the extent of proactivism done by the court to utilize or use these waste materials in the construction. And they used to what extent they can use. They give guidelines. They tell what are the precautions to be taken by using these materials. Here you can see to what extent all these materials are used. Say in lean concrete, that's the basic leveling course, we use it. 100% of this waste material based concrete can be used for lean concrete. That means up to M15 grade. I don't know whether you'll be able to appreciate or understand when I talk about M15 grade. So similarly, IRC has also came up with a new code, IRC 121 2017, that gives guidelines for the use of C&D waste in road sector. And with this code, C&D waste aggregates are used for all categories of road, including national highways and expressways. This is allowed now with this one, and it permits the use of this waste, C&D waste. For embankment, it can be used. It is allowed to use. Base courses is allowed to use. It is replacement of aggregates in PQC, that means pavement quality concrete, as well as DLC, that is a dry lean concrete, and the manufacture of curbstone, paver block, etc. It is allowed. And this waste is 100% waste can be used for curbstone and paving blocks, for footpath, cycle track, parking areas, and even full rural roads. It is permitted to use this code. You can imagine to what extent we have gone ahead in using this waste in the construction sector. And these some of the photographs of these aggregates extracted from C&D waste in one of the plants in Delhi. You can see large quantities of these aggregates are extracted from this waste stream. And one of the major use of this material was in the recently constructed new complex for the Supreme Court in Pragati Maidan, Delhi. It's a major project, and the entire walling system of this building was done using the aggregates extracted from the C&D waste. Entire walling system. Just imagine to what extent the amount that this was used. The whole blocks were using the extracted aggregates from the C&D waste. Now concrete waste. C&D waste is different because it is a mix of different types of waste. Concrete waste is a pure concrete waste. It's again a major stream of waste. And this waste is generated throughout the life cycle of a structure. During construction, during maintenance, during retrofitting, during refurbishing, all. And finally, during demolition, this waste is generated. If it can be taken out without mixing up with other waste, the construction industry has realized that is a great source for high quality aggregates. It's a source from which good quality aggregates can be extracted. And the industry is already using it, of course, not in India, outside it is used in good quantities. They came up with techniques and technologies how to extract these aggregates from the concrete. Previously it was felt to be a difficult material to recycle. Concrete was found to be a difficult material to recycle, but with this technology available, we can extract good quality aggregates from the concrete waste. What they do is they heat it and scrub it to get the aggregate. You can see these are the aggregates which is extracted from the concrete waste. And they are so clean. Probably it is better, cleaner than the natural aggregates. To what extent we can get the aggregates from the concrete waste. So let me conclude it. So construction industry has certainly participating in converting the waste to wealth through informed intervention. It is not a rough use, it's not a blind use. They have through informed intervention and their sensitivity towards environment, they have learned to use a lot of waste material in large quantities. And industry has taken various measures, and one of the most effective measures were replacing the natural resources with waste-based resources, thereby contributing to convert these waste streams, many waste streams, into wealth. Thank you very much for your patient listening.